Welcome to Geometric Galaxy. Welcome students. Today we are going to study about number system, operations on real numbers, exercise 1.4, question number 4 and question number 5. Fourth question of exercise 1.4, represent root 9.3 on the number line. We will see how to locate root 9.3 on number line step by step. First we need to draw a line and take AB 9.3 on it. From B, measure a distance of 1 unit and mark C on the number line. Now listen carefully students. We have measured AB 9.3 units and BC 1 unit. So totally the measure of AC is now 10.3. Now for the line segment AC, that is for the line segment 10.3, we need to draw a perpendicular bisector. I don't know how many of you understand if I say draw a perpendicular bisector. So I am teaching you how to draw a perpendicular bisector for any given line segment. We need to draw a perpendicular bisector to find the midpoint of AC. Now from points A and C, draw arcs with a radius greater than half of AC. That is, the measure of AC is 10.3. Greater than half of AC means it should be more than half of 10.3. More than half of 10.3 means it should be more than 5.15. So we can take any measure which is greater than 5.15. The arcs drawn from A at the top and the bottom will intersect the arcs drawn from C at the top and bottom. Now you need to connect the intersecting points at the top and bottom using a ruler. Now this line will bisect the line segment AC. So you will get the midpoint of AC. Now mark the intersecting point of the perpendicular bisector and the line segment AC as O. We found the midpoint of AC and it is marked as O. Now we need to take OA or OC as radius and draw a semicircle from A to C. Using your compass, by keeping your metal tip at O and pencil tip at A, you have a point B between A and C. From there, you need to draw a perpendicular with the help of your protractor. Name the cutting point of the perpendicular line and the semicircle as D. Now connect OD. Now B as center and BD as radius. Draw an arc to cut the number line at E. Thus, taking B as the origin, the distance BE is equal to root 9.3. Now the point E represents root 9.3 on the number line. With this, the construction part is over, but we need to prove that this BD measurement is root 9.3. As I said in the starting, we know that AB is equal to 9.3 and BC is equal to 1. Therefore, the measure of AC is equal to 10.3. Now O is the midpoint. OA is equal to 5.15 and OC is also equal to 5.5 since they are the radius of the semicircle. Now you see that line OD is also the radius of the semicircle. Therefore, the measure of OD is 5.15. Now what can you say about the measure of OB? We can find the measure of OB by subtracting the measure of BC from the measure of OC. So we know OC is equal to 5.15 and BC is equal to 1 unit. Therefore, 5.15 minus 1 is equal to 4.15. So the measure of OB is 4.15. Now let us see how can we prove that The measure of BD is root 9.3. Now see the picture. The triangle OBD is a right angle triangle. So we can use Pythagoras theorem and prove that the measure of BD is root 9.3. In this triangle, OB is the base and BD is the perpendicular side and OD is the hypotenuse. So OB square plus BD square is equal to OD square. We need to prove BD measure. Therefore, I am rewriting it as BD square is equal to OD square minus OB square. BD square is equal to, in the place of OD I can substitute the value as 5.15 and in the place of OB I can substitute the value as 4.15. Therefore, 5.15 square minus 4.15 square. Here, if you do actual squaring of 5.15 and 4.15, it will take a lot of time. It will be very difficult for you. So use the identity a square minus b square equal to a minus b into a plus b to find the answer. Now you see how the work become very simple. 5.15 minus 4.15 into 5.15 plus 4.15. What is 5.15 minus 4.15, students? It is 1. 5.15 plus 4.15 is 9.3. So 1 into 9.3 is equal to 9.3. Now BD square is 9.3. What is the measure of BD? So BD is equal to root 9.3. Hence we have proved that the perpendicular distance BD is root 9.3. Therefore, we are taking the measure of root 9.3 in the compass and we are marking it in the number line. Therefore, you need to understand from B till E is root 9.3. Now we have to consider B as the origin and E as the point where we get root 9.3. I hope you all understood this. Represent root 9.3 on number line. Further, if you have any doubts, you can let me know in comment section. Now we can start with question number 5. Rationalize the denominator of the following. Here we have 4 subdivisions. Let us see one by one. Our first subdivision is 1 by root 7. We have already done this type of question in example problems. So I hope you all know what is rationalizing factor. So to rationalize the denominator, we need to multiply and divide by its rationalizing factor root 7. Now 1 by root 7. The rationalizing factor is root 7. So multiply and divide by root 7. So what's your answer? Root 7 by root 7 square. That is root 7 by 7. The second subdivision is 1 by root 7 minus root 6. So what is the conjugate of root 7 minus root 6? Yes, you are right. The conjugate of root 7 minus root 6 is root 7 plus root 6. Let us now start solving by multiplying and dividing the conjugate root 7 plus root 6. In the numerator, 1 into root 7 plus root 6 is equal to root 7 plus root 6. In the denominator, root 7 minus root 6 into root 7 plus root 6 is root 7 square minus root 6 square. The numerator remains the same, but in the denominator we will get 7 minus 6. 7 minus 6 is equal to 1. Therefore, the answer is root 7 plus root 6 divided by 1. That is nothing but root 7 plus root 6. That's all very easy, students. Now the third subdivision is 1 by root 5 plus root 2. Here also, to rationalize the denominator, we need to multiply and divide by its conjugate. The conjugate of root 5 plus root 2 is root 5 minus root 2. If we multiply and divide by root 5 minus root 2, then in the numerator we get the answer as root 5 minus root 2. In the denominator, root 5 plus root 2 into root 5 minus root 2 is equal to root 5 square minus root 2 square. The numerator remains the same, root 5 minus root 2, but in the denominator we will get 5 minus 2 which is equal to 3. Therefore our final answer is root 5 minus root 2 divided by 3. Fourth subdivision is 1 by root 7 minus 2. The same process. What is the conjugate of root 7 minus 2, students? Yes, it is root 7 plus 2. So we need to multiply and divide 1 by root 7 minus 2 by root 7 plus 2. The numerator value is 1 into root 7 plus 2 is equal to root 7 plus 2, and in the denominator root 7 minus 2 into root 7 plus 2 is equal to root 7 square minus 2 square. You see, the first term alone has the root, the second term is not having the root. So keep that in mind while solving this type of questions. So denominator, root 7 into root 7 is 7, 2 into 2 is 4, 7 minus 4, the denominator becomes 3. The numerator remains the same, root 7 plus 2. So our final answer is root 7 plus 2 divided by 3. In this type of problems, we should be very careful. One term is having root, another term is not having root. So we should carefully do the calculation part. I hope you all understood this question. If you have any queries, you can ask me in comment. I am ready to reply you. And that's all in this video, students. Let me meet you in next video with laws of exponents for real numbers of number system. Thank you, students. If you find Geometrix Galaxy helpful, consider subscribing to my channel. And please don't hesitate to recommend this channel to your friends. Thanks for watching.